right, so in this video, I'm going to show you how to use LaTeX in Pages. So here's a document that I loaded to Moodle, and essentially I tried to find everything that we've done so far in the first 10 lessons that you may need to use, so kind of all the basics of stuff here. So if you want to see, if you want to look at these things, basically if you go on the table and you double click on that, basically what'll open up is this equation editor, and you can see all the LaTeX that was used to create that particular equation, right? And then you'll also see that in the second column that there's the LaTeX written right out there for you. So as you are writing up things in LaTeX, feel free to just copy and paste from this document. You don't have to redo everything from scratch. I do that all the time. There's no sense in writing everything over and over again because it's exactly the same stuff. So I think this is going to be a useful tool to help you rather than just going online and Googling, because I've tried to find like a really good resource, but there's so much stuff out there, and I think it's just best to kind of, at least if you're new to it, or even if you do use it, to have sort of a little index of things that you commonly use, and so that's essentially what I tried to create here for you and for me. It's useful for me too, as I try to make up your notes slides that I present. So we have the typical symbols. A lot of them, it's just whatever, there's nothing special, right? So if we look at the plus sign, on there, it's just a plus sign, okay? And you can see that over here in column 2 as well. So typically, if you want to, it's pretty intuitive to use it, and a lot of times you can guess, and you'll actually guess right once you start getting to use it. So one thing you can notice here is that the parentheses is just the parentheses, but if you want to make like bigger parentheses, right? So if you have like a fraction, if you just use a regular parentheses, it won't do that go around the whole thing. So I think it looks neater this way. I mean, I'm not gonna worry. We're not gonna mark you off if you don't use this one. But part of the purpose of teaching you this is not just because it's how we want you to present your work for the take-home portion of the exam, and if you have any redo stuff, but it's also useful to make things look professional when you have to submit documents on your own. So it's a nice little extra thing you could put on your resume. Okay, so we have the typical math symbols, basic operations. So you use the fraction a lot. This is kind of scientific notation and how to put things to another power. So there's a little difference here, and I'll have to add this to the document, but let's do that now. So I'm just going to add a row below. And so what we see here with the scientific notation, if you just want that X, I mean, you could use an X, but this looks more like a nice, neater scientific notation. So like, again, we're not gonna mark you off for using the X because we'll be able to understand it. But if you really want to learn this and put in professional documents for whatever you might be doing in the future, if you're working in a research lab or if you have to submit something, it's good to try to practice getting used to these things, okay? So it's just every code in LaTeX starts with the slash, okay? Unless it's just a typical whatever symbol, okay? So it's a slash and slash times, so kind of intuitive. And so with scientific notation, we always do 10. And I think a lot of you know how to do the caret, or when you're raising something up an exponent. But one thing you'll notice, all right, is that if you try to do more than one digit or one letter in the exponent, you have to do something a little bit different. And so here I'll show you an example of actually how to create an equation in Pages. So if you just go up to the top row here, there's the insert button, and then you go down and there's the equation button, and it opens up the equation editor. And I think I actually had to press something to get the box to be big like this. I think default it's a smaller box. So if that looks a little bit different from you, then that's not a big deal. So it's whatever you prefer. I just don't know how to actually get out of this large mode now. So if I wanted to do scientific notation, I would do times, right? And then you can see down there, it pops up the preview. And if I do something wrong, like I put the slash there, oh, it says invalid equation. All right, so bang, delete, go back. It takes a second, but it'll show up again. And then just typical with coding is you kind of want to keep things neat. So the more space you can use up, it doesn't matter if you hit the button a million times. It'll still just show up like that. Okay, so however you want to do it, I usually just leave one space, but I think it's probably a bad habit because I've noticed that it's hard to kind of read everything that's going on there. All right, so let's say I do 10 and I do the caret sign and I say I want to do 22. Oops. All right, so now it's by default, the caret only does one thing. So if you want to get away from that, what you'll do is you'll use the bracket, this bracket here. Okay, it's next to your P on your computer. You got to do Shift and then that button. And then I could do 22. And then you always have to do a close bracket, or else it'll give you an invalid equation. All right. And so let's copy that for you here. All right. And you can see the same thing will happen with the square root. So if you want to, so I did put the brackets there for that. If you just put one digit though in the square root, it'll be fine. But if you're going to do more, then it won't drag out the top bar of the square root sign. So I don't think it's a big deal. But you know, again, if your goal is to be professional, which I'm hoping that is what you'll take out of this, these little things with LaTeX, then go for it. All right, and so you can note that in the superscripts and the subscripts. So maybe as you guess, the subscript, you just use the underscore sign. And the Greek letters are essentially just, you know, what the Greek letters are. So delta is just slash delta. Mu is just slash, well, you wonder how do you spell mu, mu. Pi, we haven't really used that yet, but we will. Theta, right? And there's a difference between capital Greek letters and lowercase Greek letters. So you could see all these are, you know, except for the delta, all the rest of them are lowercase. But let's see what would happen if I did lowercase delta instead. So I'll do insert equation slash delta, and it gives me the lowercase delta. Okay, so that's something that, you know, it's not what we actually mean when we're saying change in. Okay, so we want to use the capital delta to get that triangle. All right, so your vector notation, if you want to put the arrow, you notice that I don't really put the arrows over things that are vectors, but you know, if you want to, you can. The hat is just the slash hat, then you'll leave a little space there. Okay, so if I click on that, and you'll see I left a little space there, because if I didn't have a space there, then it's going to give me an error. Okay. Okay, so I tried to put some constants in here. So things that you use typically, and I wrote over here what they are. Okay, how do you do displacement? So we did displacement a couple ways, right? We know it's delta x, but we also know that it's also x final minus x initial, same with time interval. And I put in all the equations that we have used so far for speed, velocity, acceleration, uniform motion, constant acceleration. Okay, so all right, so let's try a couple other things so you can get an idea of some other things that are not really in the table that you just kind of are going to have to figure out, that I'm going to try to point out to you so you don't freak out. But there's a lot of resources online too, and always ask me some questions if you have any questions about the latex. So so let's say I wanted to do some scientific notation, maybe the speed of light. I'm going to do 3 / times 10 carats 8. And if you want to get into the habit of using those brackets, it doesn't hurt to do that. It's just 2 extra buttons you got to click. But if that helps you remember, then you can do that if you want. Okay, and then I can do meters per second. And personally, I don't like how close the m is to the 10 to the 8th. And it seems like it's a little kind of squished. So one thing you can do is I'm gonna space here. And then if you just want extra space there, you just tap the / button. Okay, and notice how that separated it. And if I want more of a space, another one. More of a space, another one. Oh, well, that's kind of ridiculous now. So I think the one space looks nice. Okay. So I'm not going to mark you off for not doing that. I'm just trying to show you some things that make it look a little bit nicer. All right. So what about? All right. So let's say that you're doing an equation on the exam for your take-home portion, or for your redo, and let's say you need to use this constant acceleration equation. Right. So what I'll do is I'll copy all this stuff. And so if you're doing your question, and you want to show up all your work, well, then you'll put down, let me type this in, that's a good place to start. And then, let's say, okay, well, you're actually solving for delta t, the time interval. So your next step would be, all right, well, let me do this equation again, and we can rearrange this, all right? And it might be helpful to do this on paper first, just so you can follow it. But delta t would be, let's see, we have to do a fraction, so we do backslash frac. And if it's just like 2 things, you don't actually need those parentheses. Like, so when I did a over b, it was just a, b, and it makes the fraction. But if you try to do more things, then it's sort of like the superscript. So the numerator will go in one bracket, and so it'll be v final. So v underscore final, close bracket. No, because it's minus, right? Minus v underscore initial, okay, over a. All right, so to do that next one, you don't have to leave space, but you can if you want. Okay. All right, and then I'll click insert. Oh, it does not look pretty. All right, and then so you're solving for t. So So maybe your next line would be, you can copy this again. Equation. And maybe now instead we can actually put the numbers in here. So maybe it's 5 meters per second. Okay. Minus maybe the initial is 0. And let's say the acceleration, maybe it's 4 meters per second squared. So that'd be a nice way to show all your work. Okay, and you notice here, see how that the 5 and the m per meters per second, the 0, it's so squished together that to me it drives me nuts. So I think if you're turning this in to somebody professionally, then you might want to just take that moment and add the slash. Doesn't take a lot. Looks so much nicer. Okay, and then I mean, you don't have to show all your steps, but definitely the more steps you show, the more likely we can follow your train of thought. Okay, and give you partial credit if you don't quite get it perfect. All right, so from this we can see it's 5 over 4. So if you want to show 5 meters per second over 4 meters per second squared, go for it. I don't think that's necessary. I think once you do 5 over 4, right, 5 divided by 4, 1.25, right, I think you're good to go. All right, so it would just do delta t equals 1.25, space in there, and the time, the unit's going to be seconds, right? All right, and there, that's good enough. Okay, and we could send, you don't have to show the units canceling if you don't want to. It might be more time than it's worth, but you can look at this. You got meters per second over meters per second squared. So the meters will cancel, one of the seconds will cancel, and you'll be left with seconds in the numerator, which is what you would expect for time. All right, so that's basically the LaTeX portion of what you would want to show. So we're not going to accept any handwritten stuff that's typed, that's you know, if you take a picture of it or you scan it in. Part of the reason for doing this is so that we can read your work, and so that you don't lose any points because we can't read your work. And the other part of it is just that we're making this a skill goal for this course, to learn a little bit of a useful skill. So that's good. If you want to include diagrams, by all means, you can definitely take a picture, scan those in, and attach it. I mean, you guys know how to upload things into a document. So yeah, definitely go ahead and do that. That's perfectly okay. And if you want to put any explanations in words, which you might, I mean, that's, again, that helps us to understand your thinking and give you partial credit. So especially if you're not sure, I mean, if you're like, oh, I know what I'm doing, then, if you don't want to waste your time, don't waste your time. But if you're kind of hesitant and you're not, really sure, exactly what you're doing, feel free to just put some words in there and try to explain what you were trying to do, what you were thinking. And that can help you get more points, right? So the more information, the more you show, the pictures, diagrams, then that's going to help us to understand what you understand, and make things better. And then especially if you choose to do any of the redos, then you really should type in some explanations of what you did wrong, and we'll explain more of that with the redo when we go over the redo. But I think that's essentially a basic introduction to LaTeX. And I think if you just, as you go along and you just start trying these things, if you just start examining, you'll start seeing the patterns here. Okay, and there's essentially, everything we've done so far, I think, is here. Everything you'll need for the first midterm, all that stuff is here, so for you to copy and paste if you want. And there's, it may seem like a lot, but it's, you get used to it pretty quick. So another thing I wanted to point out too with the vector notation here is that when you're in mastering physics, there are buttons in there that you can insert and make these, all these kind of things. But you can usually use the LaTeX. So if you wanted to, like for homework 3, put something in, if you, one of the questions at least has you put something in unit vector notation, you can click on the box and find the thing and insert it, or you could just do /hat space I, and that'll make the I hat there, and it'll go through just the same, just as fine. All right, so I hope this was a good introduction. I'll post some more videos to help you kind of get used to this. But if you feel like you don't need it, then that's fine. Don't waste your time. If you feel like you're getting the hang of it and you want to consult other resources, go for it. So this is just meant to help you as much as you need the help. And I'll make some more example videos, and I'll show you some. I'll upload some documents of worked out stuff and what a good problem looks like. What kind of I gave you the idea of what you should be submitting for the take-home portion, and what you should and should not be submitting for the take-home portion, and what you should and should not be submitting for if you choose to do any of the redo. All right, so that's it for now, and we'll see you next time.